Good morning, everybody. This is Mr. Walker, and the purpose of this video is to go over the Big Ideas Lesson 9.1 and how to solve some of those problems. So, the goal of today is right here to decide which type of relationship is shown in a scatter plot. We'll talk a little bit about what a scatter plot is and the different types of relationships that there are. And then the central question is, what can data and data displays tell me? All right, so just real quick, a key vocabulary word that you're going to be hearing a lot today is a scatter plot. And these are three examples of what scatter plots are. And what they basically are is some sort of graph that shows a relationship between two data sets. The two data sets or sets of data are graphed as ordered pairs on a coordinate plane. So you can see in the first scatter plot over here, we have the grams of fat being compared to the amount of calories. So if you were to collect data on maybe a meal, find out how much fat is inside of that meal, and then the number of calories that are in that meal, you can compare them with an ordered pair because you would get two sets of data. In the middle, we really don't have any information about what's being compared here because there's no x axis title and no y axis title. But in the last scatter plot, you can see that they're comparing a person's age, which is some number that you can collect, with the number of pets that is owned by those people. So remember, the main purpose is to plot all of these points on a coordinate plane and then see if there's any relationship between the two things. Okay? So that's the main important thing that we're kind of talking about here. So what I would do is just go ahead and copy this information down. Remember, the main importance is to see if there is some sort of relationship between the two data sets. All right. So here's our very first example. The scatter plot in the left shows the amount of fat and the number of calories in 12 restaurant sandwiches. So if I just want to take a quick look at the scatter plot that's over here on the left, it's the same one as the slide before. They're comparing the number of fat to the number of calories in sandwiches. And each one of these dots represents a sandwich from the store. So there's 12 dots on there. So the first question that we see is, how many calories are in the sandwiches that contain 17 grams of fat? So in order to do that, we would go down to this x-axis, which represents the number of fat in grams, and find the 17. So that's going to be somewhere in between the 15 and the 20 there, and then we would go up from there. So you can see there is a dot for a sandwich that has 17 grams of fat, and then the question was, how many calories are in that? Looks like there are 400 calories in that sandwich. So we're just interpreting what these dots are to start. Question B, how many grams of fat are in a sandwich with 600 calories? All right, so the question has to do with the y-axis. So let's go ahead and take a look. I'll use a different color pen for that. So the calories, and it looks like we have 350, 400, 500, 550, 600 is right here. So we're going to go across here and find the dot, the sandwich that represents or a dot that represents a sandwich with 600 calories. And then we're going to look at the number of fat. So go straight up from there. It looks like there is 30 grams of fat in a sandwich with 600 calories. All right, and the last question is, what trends to happen to the number, or what tends to happen to the number of calories as the number of grams of fat increase? So let's go ahead and take a look. So as we get higher and higher in the fat amount, what tends to happen to the number of calories? So as I'm looking at this, as we move across, it looks like the number of calories increases. So as we go up on the x-axis, we also start to go up on the y-axis. So there must be some sort of relationship between a sandwich having higher fat and more calories. All right, so these are four different types of relationships that you're going to be seeing a lot of. There are more, especially when it comes to the nonlinear relationships. You'll be able to create lines that best fit for that. Sometimes they're not linear, but we won't get into that in this algebra course. So here's our four different types. We have a positive linear relationship, which means that as the points get increased on the x-axis, the y-axis numbers increase as well. So you can see it's kind of going up in a straight line like this. As we go higher on the x, we go higher on the y. The opposite, the negative linear relationship, is the second example. As we get higher on the x-axis, so we're going to the right, the values of the y go down. So I would probably think that this maybe x, or this the coordinate for this last dot here would be something like maybe 10 comma 1. I'm not quite sure because there's no labels, but I'm going to assume that. And you can see that the higher the x-axis, the lower the y number is. In the middle, or the nonlinear relationship, you can see it doesn't move up in a straight line. There is some sort of curve to it. So if it's not moving in a straight line, we're going to say it's nonlinear. Now this could be going up. Sometimes the dots will be going down. Something like this maybe, or something like this. But it's nonlinear because it's forming a curve. And then the last one is showing no relationship. So there's no real pattern, right? I can't see that it's going as the x number increases, the y number increases. You see how all the dots are kind of scattered around? That means that there's no pattern and there's no relationship between the dots. All right, so let's go ahead and take a look at our next example or next question. So they're asking us to describe the relationship between the data, so similar to what we did on the previous slide, and identify any outliers, gaps, or clusters. All right, so the first thing that I'm going to do is I'm just going to look and see if there's any relationship here. So it looks like on our very first example, as I increase look, first of all, we're comparing the size of the television and the price. As the size of the television, which is the x-axis, increases, the price goes up, which makes sense, right? Because the bigger the TV, the more expensive it should be. All right, so we would say that this has a positive linear relationship. As the x increases, the y also increases. The y number would increase too. All right, so we've talked about the relationship. And then any outliers. So an outlier would be something that really doesn't fit on that line that I drew, something that kind of, it might not make sense when you compare it to the rest of the data. And when I look at this, I can kind of see that this dot right here is kind of an outlier. It doesn't really fit the trend that I noticed in the scatter plot with all the other dots. So it looks like this 70-inch TV costs about $2,200, or maybe in the middle, $2,250. This one is would be considered an outlier because it really doesn't fit with the rest of the data in the dot plot or in the scatter plot. Let's see. Gaps. Is there any gaps in my data? So there is some gaps between here and here. You kind of see how it just kind of jumps from one set of data to the next without having any dots in between, that would be considered a gap. So I would say there's a gap in between TVs that cost $500 and TVs that cost $1,500. And then clusters. Clusters would be something where you see a lot of dots close to one another. Typically, if you see a group or a cluster, it's a good indication that there is some sort of relationship between the x and the y values, or the whatever two things you're comparing. So I noticed that there's actually a cluster of information here where you have all those, it looks like maybe four dots located in this section. So I would say there's a cluster in between the $0 and $500 amount TVs, right around that 30-inch size TV, between probably like 28 and 32. So that would be a cluster where you see a lot of dots, information inside of a scatter plot. All right, let's jump and do the same thing to B. So they're comparing the age and the number of pets that the person owns. So looking at this information, it looks like there really isn't a straight line going up. So there's no positive relationship. There's no line looking like it's going down. So there's no negative relationship. And there's not a non-linear, and there's no curved line that I can kind of see. This one looks like there's no relationship in this example. So this one I would say there's no relationship between the person's age and the number of pets. So why does that make sense to me? That makes sense to me because it doesn't matter how old somebody is. They might have a few pets. They might have a lot of pets. So you can see this person right here, a 10-year-old person, had three pets. It doesn't mean like somebody who's older should have more pets. You could see that this person over here who's 70 had only one pet. So there's not like a decrease as you get older, the number of pets goes down. Or there's not an increase, like the older you get, the more pets you get. There's no relationship here. So if there's no relationship, we're going to have no outliers because everything's basically an outlier. There's no gaps because I don't see any straight line to create a gap, and there's no clustering. All the dots are everywhere. All right. And our last one, this is one where we're kind of bringing it all together and we're creating a scatter plot. So it says make a scatter plot of the data and describe the relationship between the data, identify any outliers, gaps, or clusters. All right, so let's take a look. What are we comparing here? We got the uh, number of time that people study and their test scores. So before I even start to make this, let's kind of predict what it would look like. Do you think that the more time somebody spends studying, the higher their score would be on a test? Or do you think the more time somebody studies, the less they would get on a test? Let's see and find out. So I'm going to go ahead and create a scatter plot. I'm going to just draw a kind of like the first quadrant of a coordinate plane. The title for my y-axis, this would be my study time. And then the title for my y-axis, this would be their test score. I'll just put TS for test score. All right, so looking at the information on the top, let's kind of use what we have up here at the top to kind of see how big my gap in between the numbers, the interval would be. Okay, so the smallest one is 10. Then I got 20, 30. I don't have a 40, but I have a 45. And then all the way up to 120. So the largest number we want is probably a 120. And then let's do a, we'll do, go up by 20s. So we'll have 0, 20, 40, 60, 80. Oh, that's too big of a gap. I don't like the way that looks. Um, but I didn't want to go up by tens because it would be a lot of different numbers on the bottom. It would be 10, 20, 30, 40, 50. I would have 12 numbers along the bottom. All right, and looking at the y axis, let's see, the lowest grade somebody got was a 62, and the highest grade somebody got was a 97. So there's a gap of, let's see, that's about 35. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's go up by fives, and we'll start at 60. So I got to make this little like squiggly line right there to let you know, okay, I'm going to start at 60 is my first line. 65, 70, 75, 80, 85, 90, 95, 100. All right. So now that I have my scatter plot ready to go, I can start plotting these points. So this right here would be 30 minutes and a score of 80. So let's go. I'm going to use a different marker. So go over to 30, which is about right here, then go up to 80. Then the next person was 20 and 74. So 20, 74, 60, and 92. So some of you got 60 minutes. Go up to 92. 90 and 97. So 90, just a little below the 100 or right around there. 45 and 80. So somebody studied for 45 minutes. Got an 85, which is like right there. 10 and 62. So 10 minutes. Then go up to a 62. 30 minutes, 83. So I'm going to go over to 30, then up to 83. Actually, I'm going to redo that one. So 30 minutes, 83. So it should go right a little bit above this dot. They have the same number of minutes, but that person got a higher score than the first person we plotted. 75, 90. So let's go over to 75, up to 90, 120 and 70. So 120, 70, and 80, 91. 80, go over to 80 minutes, then go up to a 91. All right, so looking at this, do we see a relationship? So just like I predicted, it looks like the more time somebody spends studying, the higher their scores would have been. So I would say there's a positive relationship with this. Now, this person right here, I would definitely consider an outlier. I would have thought he would have gotten a higher score studying for 120 minutes. Okay. I don't really see very many gaps in our information. There's not like a huge gap there. Everybody's kind of in between this 30 minutes to 60 minutes of studying. So I don't see any gaps, and I don't see anything clustered. You might be able to argue that there's a cluster here, but that's just because I have two pieces of data, which is not a lot. 20% of the data is right there. But the main thing is that there is a positive relationship and there is one single outlier, somebody who really doesn't fit the trend that I noticed. All right, everybody, make sure that you guys have your notes completed and that you start on your big ideas 9.1 the day that you come in to see me. Have a good rest of your day. I'll see you.